All right, everyone, let's get going on this. This is the last assignment for chapter 5.5. So if you didn't catch this, this is homework 5.5, part 2. And if you could label it just like this, that would be great. It'd be better if you could put the page number 383 and the assignment number. So this is number 41, 42, 45 through 48. So 45, 46, 47, 48. All right. Let's get going on this. 41. You're going to use the half angle formula to find the sine and the cosine of 15 degrees. All right, so I'll do it both at the same time. So sine of 15 degrees, and we'll do cosine. And we use blue and green. Okay, so we're going to use the half angle formula, which means that to get 15 degrees, we would be using 30 degrees. So we would rewrite this as sine 30 degrees divided by 2. This means we would actually be doing the square root of 1 minus cosine 30 degrees over 2. Right? So keep in mind that the formula states that it's 1 minus for the sine and 1 plus for the cosine. So cosine of 30 degrees, you got to figure that out. All right, so it's going to be 1 minus, and keep in mind that minus is always going to be there. So cosine of 30 degrees is going to be radical 3 over 2. Over 2. I keep working on that. Get a common denominator, so put a 1 underneath the 1 and multiply both top and bottom by 2. And you will get 2 over 2 minus radical 3 over 2 over 2, which would get you 2 minus radical 3 over 2 over 2. And by combining or doing some multiplication of 2, you will end up, and I'm not going to show this step. Actually, I should show this step just this one time. Multiply by 2 over 1 and by 2 over 1. And keep in mind that 2 at the bottom is really a fraction of 2 over 1 as well. Right? So when you work that out, you will end up with these two canceling. And on top of that fraction, you will get a square root of 2 minus radical 3. And the bottom is 2 times 2, which is 4 over 1, which is still 4. Right? And then to wrap it up, you're going to go ahead and do the square root. The top, which is just going to remain square root of 2 minus square root of 3. And the bottom, the square root of 4, is going to end up being 2. So we're going to go ahead and rewrite this as square root of 2 minus square root of 3 over 2. All right, and then we need to check to see if this is a positive or negative. We're talking about sine and 15 degrees. So thinking about it, right? Unit circle, right, or your circle. 15 degrees is sitting about right here. Okay, so if this is 30 degrees, 15 degrees is sitting about right here, and we're talking about sine. So the sine would be positive because I would have to go up. So this would be a positive answer, which means I don't have to do anything. But if you like, you can put a little plus, right? And this is my answer. Okay, cosine is very similar, except you start off with green. Except you start off with cosine. So cosine of 30 degrees over 2. This is going to equal square root of 1, and then the cosine is going to be a plus cosine 30 over 2. And I can pretty much just copy all of these steps down. This is going to equal square root of 1 over 1 plus maybe I don't want to do that yet. 1 plus, and cosine of 30 degrees is the same as this one right here, right? So it's the same as that. It's still radical 3 over 2 over 2. And you get a common, or we're going to make that 1 into a fraction of 1 over 1, which means times it by 2. You get 2 over 2 plus radical 3 over 2 over 2. And that gets you 2 plus radical 3 over 2 over a much bigger 2. And that's going to get you radical 2 plus radical 3 over 4. Square root both the top and the bottom. So you're going to get radical 2 plus radical 3 over radical 4. And the only thing we can do is that radical 4. So we will get radical 2 plus radical 3 over radical 4 is going to be 2. And that is your answer. And again, before we do that, we're going to go up here and cosine for that 30 degrees. Cosine is going this direction. Cosine is the x value. So we're going to the right, which means positive. So this answer would be positive. And again, if you want, you can put a little plus in front of it just to denote that you've checked it. And your answer is that. Okay, that was 41, 42. 42 is 165 degrees. So we want to do the sine of 165 degrees. And we also want to do the cosine of 165 degrees. Okay, so 165 times 2 is what? 200, 330, I think. Let me double check in my calculator. Yep, 330 degrees. So by doing this sine 165 degrees, we can rewrite this as sine of 330 divided by 2. Which means when we're setting this up, it's going to be 1 minus cosine 330 degrees. All right. So all you have to do is figure out what cosine of 330 degrees is. So if I'm going into my unit circle, 330 degrees, cosine is just a radical 3 over 2. Okay. So you know what? I mean, if you're looking at all of this, that looks exactly like what we did earlier. Right here. Right here. If I remove the 2's, right here, it looks exactly the same. It's 1 minus radical 3 over 2. And that's what we have. 1 minus radical 3 over 2 over 2. So, I mean, it all works out pretty much the same. Right? So I can just say, you know what? I know the answer. It's going to end up being radical 2 minus radical 3 over 2. Right? And the sine 165 degrees. Okay, so in our unit circle, let's take a look back at a unit circle right here. In our unit circle, 165 degrees. Okay, so, oops. Let me ungroup that. So 180 is right here. 150 we know is right here. So 165 is somewhere in between there. Okay. So if I have a sine, to get to this spot, I actually have to go up. So this would be the y value. So it's positive. So my answer, and I'm using my previous problem as part of my solution, but this is going to be a positive 2 radical radical 2 minus radical 3 over 2. And then if that's the case, then that means that my answer for the cosine of 165 degrees, this is again utilizing 330 degrees divided by 2. Right? And that actually will give me the same answer. Okay, this will be radical 2 plus radical 3 over 2. And again, go back to my unit circle to figure out. Again, remember, we're using the same thing because it's going to give me the same answer, the same basic answer. Right? But for cosine, to get to this spot right here, I have to actually go to my left. I have to actually get to this spot right here. So left means negative. So that means that this answer is going to end up being a negative answer. Okay, which is different from this one up here because that's a positive answer. So my answer is negative radical 2 plus radical 3 over 2. Okay, so I did a couple cheap shots right there, and I cheated a little bit by utilizing my previous problem, but I don't see why not when you're basically going to get the same answer. All right, so that's the 2 degrees, and the degrees are usually easier to kind of manage because degrees, it just actually makes more sense. Then we have 45 through 48. Actually, I'll work on the next page. How about that? So 45 is, we want to do pi over 8. So this will be sine pi over 8. And we would be doing cosine pi over 8. Remember, we actually want to look at the double of that. So if you have pi over 8, and I know Mizell did this during third period, but if you want to do a double, you want to know if this is a half and you want to see the double of it, all you really have to do is just multiply it by 2, which is gonna get you 2 pi over 8. And if you reduce that divided by 2 each, you're gonna get pi over 4. So pi over 8 is actually half of pi over 4. So that's what we're going to use. Sine of pi over 8 is actually the same as sine of pi over 4 over 2. All right, and that's going to be the same for both of these. So cosine of pi over 8 is the same as cosine pi over 4 over 2. All right, and we can start this off. So sine is going to be square root 1 minus, and then we got to figure out what cosine. We got to figure out what cosine of pi over 4 is. And then all of that divided by 2. And you can do both of these in parallel, in tandem, because the cosine is exactly the same. It's just plus instead of a minus. Heck, I'll do both of them at once. I'll take them both of them. All right. Now you just got to figure out what cosine of pi over 4 is. So go look at your unit circle, cosine of pi over 4. Give you a couple seconds. Okay, it's going to be, so cosine of pi over 4 is going to be radical 2 over 2. And then you still got to do over 2. So same thing on the cosine. I do a 1 minus, or actually 1 plus, radical 2 over 2 over 2. Right, common denominator, or make it into a fraction. Both of these. Common denominator, multiply by 2. Heck, multiply by 2 here also. Right, and you're going to end up with square root of 2 over 2 minus radical 2 over 2 over 2. That's a lot of 2's. Right, over here, you're going to get square root of 2 over 2 plus radical 2 over 2 over 2. combine them together, the two radicals, or the two fractions, excuse me. So you would get 2 minus radical 2 over a simple 2 over a 2. And this one right here, 2 plus radical 2 over 2 over 2. All right, and how I did last time, I multiplied it by 2 over 1. So I'm not going to show you this time around because it's the same process. So you're just going to have a radical 2 minus radical 2, and the bottom 2 cancels, and then you're going to actually end up with a 4 at the bottom. So it'll be 2 plus radical 2 over 4. And then when you separately radical or square root each of them, you will end up with just a radical 2 minus radical 2 square root of 4 is just 2. And no, you cannot cross any of these out. And this one will end up with radical 2 plus radical 2 over 2. All right, now time to look at where this is going to stand. So I'm not sure where pi over 8 is. All right, so here's my unit circle. I'm going to just draw a small one in the middle. I'm not sure where pi over 8 is, but I know where pi over 4, and then pi over 4 is the double. Right? Remember, if we double pi over 8, we'll get pi over 4, and then we divide it by 2, which would get us pi over 8. So I do know where pi over 4 is. It's in the middle here. So if I want to figure out pi over 8, it's half of that, which means that we're talking about this point right here. So it's halfway. Okay. And for my sine, it's going to be positive because I will be going up. And for my cosine, it would be positive also because I would be going to my right. So both of those are going to be positive and positive. So both of these answers are positive and positive. Okay. That's 45. I'll change it over to, well, doesn't matter, 46. Okay, we got pi over 12. So we want sine pi over 12 and cosine pi over 12. And again, we're going to use my Zel's method. Pi over 12, if we want to figure out what double that is, you just multiply it by 2, and that gets you 2 pi over 12. Do not multiply the bottom by 2 also. The bottom is actually a 1, so it's 2 times pi and 1 times 12. Okay, and 2 over 12, 2 pi over 12 actually gets you pi over 6. So that's what we want. We want to do the sine of pi over 6 over 2. And we want to do the cosine of pi over 6 over 2. I'll email. All right, so we'll go with that. And again, I'm going to do both of them in tandem because why not, right? I'll take both of them on. I'll take 3 of them on. So this is going to be square root 1. So sine is minus cosine and pi over 6 over 2. And cosine is positive, so 1 plus cosine pi over 6 over 2. Right, only thing left to do is really figure out what cosine of pi over 6 is. Right, so take a minute to look at where cosine of pi over 6 is. And cosine is radical 3 over 2. Okay, just like, I think we did this earlier, 30 degrees. Yep. It's actually going to be the same answer as the 30 degrees. Interesting enough. Because, yeah, so I'm just going to go ahead and write this down. You can copy all of that work, but you know what? I am pressed for time, so it's going to be and only the core problem, right? We still got to look at, is it positive or negative, but only the core problem. So it's going to be 2 minus radical 3 over 2 and 2 plus radical 3 over 2. So at the end of the day, you're going through all that work, I will get. Okay, again, this is the same as the very first one that we did. Right, number 41. So this will end up being square root of 2 minus square root of 3 over 2. And this one you will get square root of 2 plus square root of 3 over 2. Right? And that 2, those 2's are not in the square root anymore. Right? And I don't know where pi over 12 is. Okay? But I do know where pi over 6 is. Okay? So pi over 12, I don't know, but pi over 6 is this first marker right here. So that means that pi over 12, so pi over 6 is that mark right there. Pi over 12 is half of it, which means it's right there. It's even smaller. Okay? Which means that my sine is going to be positive because I still have to go up to get there. My cosine is positive because I still have to go to the right. So these right here, my answers are positive and positive, just like number 41. And I'm willing to bet if somebody converts this over pi over 12, you will get 30, or you will get 15 degrees. So that's the bell for the after school. 47, we got 2 more to go through. 47 is 3 pi over 8.
Hello everyone, we got Flagordi Group Club.
Disregard that.
Upward bound is room 201.
Which means I need to do sine of what? Over 2, right? So again, using my Zell's method, 3 pi over 8, and I want to double that.
And then the late buses are
this will be 6 pi
and 6
over 8. And if I divide each one by 2, I will get, divide each of them by 2. That was weird. Divide each of them by 2, I will get 3 pi over 4. All right, so that's what I'm using. So sine of 3 pi over 4 over 2.
We also have Nami Club in the cafeteria.
And if you didn't catch all of that, pause it and take a minute to look over it, okay? So before I erase it, of course. So cosine 3 pi over 8 is the same as cosine 3 pi over 4 over 2. Right? And that's where we will start. So it'll be square root 1 minus then cosine 3 pi over 4 over 2. And this one will be square root 1 plus cosine 3 pi over 4 over 2. Right? Now that's all that's left is for me to go and find out where 3 pi over 4 is. Okay. So 3 pi over 4 is over there. So that, and the cosine of 3 pi over 4 is negative radical 2 over 2. So you will have 1 minus a negative radical 2 over 2. Okay, you got a double negative thing going on over 2. Okay, and this one is going to be positive, but it's still going to be negative. So it'll be 1 plus a negative radical 2 over 2 over 2. Right? So that those double negatives are going to combine. So it's going to be 1 plus radical 2 over 2 over 2. And this one's going to combine to be a 1 minus radical 2 over 2 over 2. All right. So combining that, I'm going to put a 1 over 1 and multiply by 2. So I'll get 2 over 2. And I'm skipping a couple steps. So look back through some of the other videos if you're a little lost about where I got 2 over 2. So 1 plus, radical 2 over 2 plus radical 2 over 2 over 2. That's a lot of 2's again. And this one will be, again, the 1, I'm changing it to 1 over 1. and then multiplying that by 2 over 2 to get a common denominator. So I'll have 2 over 2 minus radical 2 over 2 over 2. Okay, and this will give me 2 plus radical 2 over 2 over 2. And this one will give me 2 minus radical 2 over 2 over 2. Okay, same thing, and multiply top and bottom by 2 over 1, and that's going to basically get rid of that 2 from the top bottom and double the times it by the bottom by 2. So I will essentially have 2 or radical 2 plus radical 2 over 4. And this one I will have radical 2 minus radical 2 over 4, which is just going to give me a 2 at the bottom. So my final answer, radical 2 plus radical 2 over 2 and radical 2 minus radical 2 over 2. Right now, again, answers look pretty similar as any other thing, but what matters is the point, right? So, or where am I at? So, um, let's see. I'm looking at, so this is how you would go about it. So I'm looking at, so first off, I don't know where 3 pi over 8 is, but I do know where 3 pi over 4 is, and 3 pi over 8 is just half of that, right? So I don't know where 3 pi over 8 is, but I do know where 3 pi over 4. And if you look on your unit circle, 3 pi over, where did, look on a unit circle, 3 pi over 4 is sitting over here. 3 pi over 4 is right smack in the middle, right? And 3 pi over 8 is half of that. So imagine if this, if this was split in half, right? Where would the halfway point be at? I'd say, well, that's probably a little bit off. I'd say more like this. That would be right around the halfway point. Okay. So for that point, what's my sine? Sine is a y. So for the y, I would have to go, it would be going up, right? And the cosine, well, cosine would be going to the right. So they're both positive. Right is positive and up is positive. So my signs for that are both positive, positive. Oops. Positive and positive, and that's my final answer. Okay, so that's 47. So this is the sine of 3 pi over 8, and this is the cosine of 3 pi over 8. Okay. Okay, last one, 47. So this is 48. 48, we're looking for 7 pi over 12, and we want the sine of 7 pi over 12 and the cosine of 7 pi over 12. Right, using my Zell's method, I'm going to cut to the chase. Some of you guys may have figured this out by now, but if I want 7 pi over 12, I would have to do sine of 7 pi over 6 over 2. And cosine would be cosine 7 pi over 6 over 2. So what I'm really looking for is 1 minus the cosine of 7 pi over 6 over 2. And this one is square root of 1 plus the cosine 7 pi over 6 over 2. Again, on the unit circle, you just got to go around till you find 7 pi divided by 6, right? And that's the only real trigonometry you're doing. The other part it's just algebra. So you end up with 1 minus, and cosine of 7 pi over 6 is a negative radical 3 over 2 over 2. So this one, so on the cosine of 7 pi over 12, I will have square root of 1 plus a negative radical 3 over 2 over 2. So this one looks like it's the backwards of one of the previous problems. Okay, but it's okay. We'll work this one out since it's the last one anyways. All right, so you will have 1 plus, because of negative negative, radical 3 over 2 over 2 for the sine, and for the cosine you will have square root of 1 minus, because of plus minus, radical 3 over 2 over 2. Okay, and by doing changing the 1 to a 1 over 1 and then multiplying that by 2 and then combining it, I'm just going to go ahead and cut to the chase. You will get a 2 plus radical 3 over 2 over 2. And on this one, you will get again, change the 1 into a 1 over 1, multiply top and bottom by 2, so you get 2 over 2, and then combine those, so you will get 2 minus radical 3 over 2 over another 2. Multiply top and bottom by 2 over 1, like how we did the first problem. If you don't remember, go back to it and watch it slowly, step by step. This will end up with a radical 2 plus radical 3, and the 2 on the bottom cancels, and then the 2 on the bottom of the bottom, the 2 on the bottom is going to turn into 4. And the cosine is going to be radical 2 minus radical 3 over 4. Okay? And by square rooting both sides, you will end up with radical 2 plus radical 3 over 2, and radical 2 minus radical 3 over 2. Now we got to look at where this is headed, because again, I'm not sure where 7 pi over 12 is, but I am sure I know where 7 pi over 6 is. And 7 pi over 12, it's just half of 7 pi over 6. Okay, so 7 pi over 6 is, where's my unit circle? Oh, let me get rid of all this stuff. Okay, so 7 pi over 6, take a minute, look on your unit circle. It's the very first mark below the 180 degrees. So 7 pi over 12 is, so imagine this. If this is 7 pi over 6, where's the halfway mark? Okay, I'm thinking it's probably about right here. Okay. Now we know it's not straight up and down, because that would be halfway from the 180. It would be straight up and down right here. All right, so we know it's not that. So we know it's a little bit past 90 degrees. So 7 pi over 12 is going to sit right here. And that is 7 pi over 12. Okay. And so when I do the sine, if the sine is going to be, and if, let me get rid of this stuff. So the sine is going to be up, which is positive. The cosine is going to be to the left, which is negative. Right? So when I do my cosine, it's going to be negative. And when I do my sine, it's going to be positive. And those are my two final answers for number 48, or the sine and cosine of 7 pi over 12. Okay? All right, get this one in. If you need last minute help, this is it. It's due by midnight. All right, if you have any questions on anything, email me. I'll try to check my email. No guarantees, but I'll try to check my email. Have a good night.